The clock just turned to 4 in the afternoon, so let's get started with this talk by Jimmy about Google Maps. Let's go. Let's give him a hand.
Thank you. So, Mom, can we have Google Maps in a way that will not be indexed by Google? So that's why the spelling. We have Google Maps at home. What does that mean? My name is Jimmy Angelakos, or Angelakos if you're not an English speaker. And I'm a systems and database architect. I work at Deriv, and thanks to Deriv for sponsoring this trip to PGConf.EU. I'm originally from Athens, Greece, but I'm based in Edinburgh in Scotland. I have been an open source user and contributor when I can contribute to a project, I try to do that over the past 25 years, and I have been using Postgres exclusively in the past 16 years as a database. I have also written a book called PostgreSQL Mistakes and How to Avoid Them, and I've co-written another book with some brilliant fellows some of whom are in the audience, and the late great Simon Riggs, called PostgreSQL 16 Administration Cookbook. I have also written a Postgres extension called PGStatVis for visualization of Postgres internal statistics. So what I am not, and what this talk is not about, um, is I'm not a GIS expert. So if you came for this sort of content, you may be disappointed. Can I see a show of hands? Who are GIS people in here? One is two, three. Cool. So this is the right audience. This is not. This is a good audience mix. This is not an in-depth analysis of GIS, and it's not a detailed how-to. I'm not going to tell you exactly what to do or how to do it, but I'm going to show you some new capabilities that you may not have been aware of. Because the GIS subject, as three people in the audience know, is too extensive to cover in 45 minutes. So what is this about? It is about raising awareness for the combined potential of Postgres with GIS tools and PostGIS or PostGIS or PostGIS. All three pronunciations are valid since none of them are official. And OpenStreetMap is something we're going to be talking about as well. I have tried these things and saved you some time. So you can learn from what I did with these tools. So what are geographic information systems, or GIS for short? They're software for geodata. And what is geodata? Software, it stores, it manages geographical data, performs analysis on this data. You can edit geodata with GIS software. You can output it to different formats, and you can also visualize it and put it on a map or other sort of visualizations. But what can you use GIS for besides the obvious, which is storing maps? When you associate data with a location, you are creating effectively geodata. And that's what we refer to when we say geodata. And what are the applications for geodata? There are lots. The key applications, I believe, are governance. If you know, if you can combine governance data with geolocation, then you can have a better understanding of what needs to be done. Environmental science is a key application. Health. If you remember, 4 years ago, we had a minor health issue across the globe. The most popular website was a map during this time. The most popular website in the world was a hospital's map showing where the new cases of this virus were found, and also showing you the statistics and correlations for those locations. History and archaeology. You're in Athens. You will find geodata in every museum that has ancient stuff in it. And also cultural and social study. Now that we're all together and it's one big globe, um, it is a way to preserve and record differences in culture, local dialects, music, etc. Specifically, what can you use GIS in the database for? You can build location-aware services. You are now all aware of this because nearly all of you have smartphones and they have location-aware services in them. For example, you can search for a point of interest like a cash machine in Athens. You can search for the nearest cash machines. You can find out what your current time zone is. You can find what the current weather is where you are, and you can find events in your current location. And you can also associate things with GPS coordinates, which means that you can perform spatial queries. Um, and that's especially useful for joins. If you want to correlate you want to perform a query and you want to correlate this query with a location, then you perform a spatial join. So, how does this all work? How Oh, sorry, forgot routing. Routing is quite important. You may have noticed here in Athens, we have a lot of delivery drivers going about on scooters. This is an application of routing, how to get from A to C via B, in order to have the optimal route to deliver your food. So, how does this all work? How do I get geodata in my Postgres instance? We mentioned PostGIS. It's an extension that allows you to create and manipulate geographical objects inside of Postgres. It supports probably any kind of spatial type and any kind of spatial query you can think of. This is software that has been developed over more than 20 years. It has a lot of functionality built in. It is based on what are called lightweight geometries, and this means that the geodata you store in PostGIS can be indexed very well, and they have a very small memory footprint. Um, all of these things now make Postgres the de facto industry standard in spatial databases. You will find that most people who know what they're doing with GIS may not be using Postgres as their primary tool, but they certainly have Postgres with PostGIS somewhere in the backend. However, the Open Geospatial Consortium hasn't certified it. Now, PostGIS, um, as we said, takes advantage of indexing, so it's really, really fast. It can pretty much instantly return spatial containment results, which is, does this point belong inside the area defined by this geographical object? So, is this set of coordinates inside a lake or a city or any other kind of geographical object? It can also perform distance calculations, which are complicated because unfortunately the Earth isn't flat. And it can tell you how far. I see shocked looks in the audience. Uh, and it can also tell you how far away 2 points are from each other. But you can also perform advanced queries, such as the K nearest neighbor search, which means what are the nearest candidate features to this query feature. So you can say, what are the nearest shops that serve espresso near the Divani Carvel Hotel? Now, in order to obtain this geodata, you either have to buy it because it's proprietary, and proprietary geodata providers traditionally have been MapQuest, here, Google Maps, TomTom, Bing Maps, Esri, etc. Coincidentally, These are the founders of the Open Geospatial Consortium. Also some service providers. So instead of purchasing the data directly, you can access it from their APIs, like Mapbox is a very old one. They started when the World Wide Web started, Amazon Location Services, and so on. But we also have open data. And we're going to talk about OpenStreetMap, which is a great source of open geographical data. There's also Wikimapia. It's kind of abandoned and kind of a questionable group that runs it. So we're mostly going to focus on OpenStreetMap. Let's just briefly mention the Linux Foundation's attempt to provide free geographical data called the Overture Maps Foundation that you may be or may not be aware of. These are the founding members. I will let you draw your own conclusions. So instead, let's talk about OpenStreetMap. What is OpenStreetMap? It's a free and open geographic database. It was created by a British fellow called Steve Coast in 2004. Why? Because the mapping agency of the United Kingdom, called the Ordnance Survey, refused to release its data that was publicly funded. The adoption of OpenStreetMaps accelerated in 2012. Does anyone know what happened in 2012 that drove this? One person is nodding. Google started charging for maps in 2012. Now, here's the really interesting part for me. It's collaboratively updated, OpenStreetMap, I mean, and it's maintained by the community. Its database is hosted by the OpenStreetMap Foundation. It is not controlled by any other entity. And this brings us to why OpenStreetMap is important. You can consider it the Wikipedia of geographical knowledge. I think that's a good analogy. And because of its governance. It is a UK-based nonprofit, but it has local chapters like in the United States. And mainly because of the licensing. The data inside OpenStreetMaps is licensed under the Open Database License, which is attribution, share alike, and keep open. It's a kind of copyleft, which means that you can do whatever you want with this data, but you must keep it open. So OpenStreetMaps apparently is quite popular. It's being used by tons of websites, apps, and tools, even if it's not visible to the end user. Now, let's see what is inside OpenStreetMaps data. And let's talk about the data primitives in OSM. First of all, we have nodes. Nodes are just coordinates by default in the WGS84 reference system for coordinates. They are features without size, right? They're points on the globe. They can be a geographical point or they can be a point of interest. These are nodes. Ways are lists of nodes that are ordered into lines or polygons. And these form features like streets, which are linear, or they form areas like, for example, lakes. These are ways and they are comprised of nodes. Relations are ordered lists of nodes, ways, and other relations that show you the relationships between these items. And finally, tags are how you encode metadata. Um, for those taking photos of the slides, I'm going to put them up on the website, so don't stress. Tags are key value pairs for the metadata associated with the objects that we just mentioned. So you can encode in OpenStreetMaps additional knowledge and additional metadata on top of nodes, ways, and relations. Okay, so we've talked about maps, we've talked about OpenStreetMaps. Where does Postgres come into this discussion? OpenStreetMaps, the server, uses Postgres underneath. And it holds its data in tables of those primitives that we just mentioned. The individual objects are stored as rows inside of those tables, and you can export the data freely, and you can also import OSM data into your own database because it makes the OSM makes available dumps of any kind of size. So you can dump planet OSM, which is the entire data for the planet of Earth, or you can export an individual country or an individual city. And there are people that create those dumps and graciously provide them for other users for free. And the formats that they come in are PBF, but also XML. So they are really interoperable. Anyone can take this data and do whatever they want with it in any sort of tool. So speaking about tools, how can we use this OpenStreetMap data? Because as far as we're concerned right now, OpenStreetMaps is a website, right? And it has maps on it. How do you extract this data and how do you use it yourself without being dependent on that website and the kindness of strangers? So you get direct access to objects through an identifier called an OSM ID. Every object in OpenStreetMaps has an OSM ID. And you can perform with this identifier, of course, spatial queries. And you can also do cool things like geocoding and reverse geocoding. We will talk about that in a moment. Another cool thing you can do with this data is you can integrate map displays with a map server that you run yourself on your website. So let's take a moment to discuss geocoding and drink some water. That's, by the way, that's a screenshot from Nominatim, which is a geocoding tool. What is geocoding? Geocoding is a search that returns the coordinates of what you searched for. So if you're searching for a place or feature, geocoding returns the coordinates for that. So you give an address or a name of a location or a feature on a map, and you get back coordinates. Reverse geocoding, surprisingly, returns the data on this place or feature when you provide the coordinates. Cool? It's really simple. What geocoding tools can we use? I mentioned Nominatim. There's a free implementation and a reference website up on nominatim.openstreetmap.org. You generally shouldn't link to that and depend on that for your application because it's freely provided and has usage limits. But it's open source software. You can install it and you can run it wherever you want. A non-Postgres geocoder you can use is Photon. And there are also other geocoding tools that you can find on this wiki page. Again, the slides will be up on the web, so you can click on those links and hopefully they'll work. So, okay, you've spent 17 minutes talking about maps in general. What is the basic idea behind this talk? Why is it called Mom, Can We Have Google Maps at Home? You can avoid relying on external dependencies that are usually expensive, such as geodata APIs. So you can use this data to your advantage. You can use OSM data and put it inside your Postgres to take this in-house instead of relying on someone else's API. You can query the data directly, or you can create services that use API that you run yourself. And how do you do that? In conjunction with open source GIS tools that we will talk about shortly. So first off, how do you obtain the OSM data? It is as simple as opening a torrent client and downloading Planet latest OSM.pbf, which is the dump of the entire data of OpenStreetMaps for the planet of Earth. Torrents are legal. Don't let anyone tell you otherwise if they're used for the proper purposes. Okay, now you have a huge file that's in the terabytes, and you need to ingest it into Postgres. Or you don't have to download the planet-wide data, right? You can choose smaller data sets, as we said, that people make available. So there are standard ways of ingesting OSM data into Postgres. One of them that is very popular is PGOSM Flex, and you can click on the link and it will take you to their website. When you run PGOSM Flex on the whole planet data, the ingestion usually takes about 1.5 days, no matter how fast your machine is, because all of this data that's encoded in the PBF or XML dump needs to be disentangled and inserted into tables and correlated with each other, as we mentioned. So it takes some time. But once this is done, subsequent updates to the data are much, much faster. So you can download the increment of changes since the last time you downloaded the planet data, and that will apply much faster. So PGOSM Flex comes in a Docker that you can run. You can also pass, necessary locations like where the data is and where your Postgres is. Uh, Passwords, never on the command line, please. Um, and you can also specify Postgres tuning parameters that are optimized for loading geodata. And the makers of PGOSM Flex kindly provide some examples of configuration. So you can see that I'm configuring their shared buffers, workmem, maintenance workmem, things that will help the ingestion work faster so that you don't have to uh, configure your production server differently. This runs a Postgres instance inside of a Docker container that transforms the data and can insert it into your main database. You can also see some dangerous settings that are only useful for performance, such as fsync equals off. Don't do that in production. Don't. So, a long time later, your data is ingested. How do you use it? Let's see an example with nominatem. So you can index it with this geocoder, and you can use the geocoder as an API with some flavors that it comes in. So it was originally written in PHP. Fortunately, there's a newer version in Python, so you can install that as a service using your favorite Python serving tools, and you then query the API. So it's as simple as issuing a curl call or whatever library you're using for HTTP calls. In this case, I'm querying the free service, nominatem openstreetmap.org, and I'm searching, for example, for Chicago. That's my query. Or you can query locally if you've installed the API locally. And you can also specify parameters such as format. I want the answer to this query to be provided to me in GeoJSON format. And we'll see that this looks like this. I'll zoom in. So when we get the data for Chicago back, we see that we get a list of features in the response that is provided in GeoJSON format. And we see that we have an OSM ID that represents the geographical feature that is called Chicago. It is an administrative boundary. It provides the name and the local language and the display name that appears on maps. And it also provides, because it is GeoJSON, it provides a bounding box, which means that the entirety of Chicago fits inside this box. And these are the corners of the box on the map. And also, there's a geometry point that is the center of Chicago, and that is also provided with its coordinates. Or you can query other places like Thessaloniki, which is a city in the north of Greece, and it has a different OSM ID. It is a place, it is a city, and the name in the local language is this thing. The display name is Thessaloniki in all of the administrative things that it belongs to. We briefly mentioned Photon. Photon isn't Postgres specific, but there is a connection. It's written in Java and Elasticsearch, which means that you can search as you type, which is a cool feature. And additionally, unlike Nominatim, it is typo tolerant. Nominative performs uh, exact searches. So if you misspell something, you don't get results back. With Photon, it performs fuzzy searches. So even if you misspell something or use a non-standard spelling for a feature or a city, you do get results back. It's multilingual, so you can query it in any language. And you don't need to create the indexes yourself. They are provided and regularly updated, like once a month, and you can download the Elastic indexes from a website. However, if you wish to do that locally, you can update your Photon with the data you have in your Postgres. So you can export data uh, using Postgres and Nominatim and stick it inside of a Photon index. And there's also a Python library that you can use if you find Java distasteful, and it's on GitHub. So how do you query Photon? Again, curl localhost port 2322, and the query is Chicago. It doesn't matter if I've spelled it with a lowercase c; it will still work. So, and the results will be the same, right? I'll get the GeoJSON that I got with Nominative in the same answer. Now let's choose a location in Chicago near the center. So 41.85 minus 87.65. And I know that this location is inside Chicago, but does my software know that? I will need to perform a spatial query to verify that this point is indeed part of the Chicago map. So I write a query in PostGIS with the function stcontains that returns yes or no if these points if this point that I provide is contained inside a place. So I'm selecting the geometry of Chicago, which is OSM ID 122604, from the table place that contains all places. And then I'm joining it. Sorry, I'm not joining it. I'm running the stcontains to see if this point that I'm creating with stMakePoint for these coordinates in the reference system 4326, does this point fall inside the boundaries of Chicago, the object? It does, unsurprisingly, because I chose it. Let's choose another location that may or may not be inside the administrative boundaries of Chicago. So I create another point. You will notice that for ST make point, you have to put longitude and latitude in the reverse order. That's how this function works. I don't know why. Maybe the GIS people know why. So, still Chicago, OSM ID 122.604. Is it true or false? It is false. And this is super fast and performant. Uh, so you can always tell where um, a pair of coordinates belongs, right? Does it belong in a city? Does it belong in a country? Does it belong in a continent, in a lake, on a street, etc. Now let's see joins. How do joins help me? Which is more interesting for the database inclined among us. So you can select customer ID, let's say, from customer addresses, and I'll use the alias CA for customer addresses, and I can join it with my geodata that I have inside PostGIS. And so OSM ID 122.604, which is Chicago, I will join CA longitude and latitude with that I have stored in my customer addresses. I will join it with place to see if this address is inside Chicago. So you can see that we have various use cases that emerge with these sorts of capabilities. You can find objects and you can determine the area that they are in or the jurisdiction that they are in. You can also um, understand that passing the object type is super powerful, right? You can say that I'm looking for a city specifically within this area, and it can return that within the blob that I've drawn on the map, there are a couple of cities. One is Chicago, the other is Evanston, Illinois, for example. Um, you can deduplicate addresses, which came in handy when I had to do this because you know that people may write their address in different ways. And you know that there are things such as, well, not in Greece, but in the UK, you can have buildings with multiple postcodes, depending on which entrance to the building you're using. So you can have companies that are co-located in the same building having different postcodes, right? And the postcodes may, through geocoding, end up having different points on the map, even though they're in the same building, because that's the way they were encoded. So, how do you find if two things are co-located? For my application, it was good enough to determine if the geocoded coordinates were within 100 meters or 300 feet of each other. I consider that close enough to say that these two addresses of my customer are the same address, for instance. Is that clear how you can do this? You just figure out the distance between 2 points. You have the points already in your customer database. Are these within 100 meters of each other? Then the two addresses that I have for this customer are probably one and the same address. You can also normalize addresses because with geocoding, you don't have to worry about parsing addresses, right? You avoid the hassle of writing the software that determines if two addresses are the same yourself. And you can standardize the way that they're displayed because the customer may have typed in a partial address or they may have misspelled their own address. That happens too. So you would like a geocoder to standardize the stuff that's making it inside your database. You can use other tools, such as Leaflet is a JavaScript library that you can use to display maps served directly from Postgres and map servers, such as GeoServer and Map Server that you can run yourself on your own servers. There is also a hugely popular tool called QGIS um, for manipulating and retrieving and analyzing geodata. And there's also another map server called Mapnik that you can again use for free. It is open source and free software. Now, that's about it for the content of this talk. Um, let's keep in touch. I have a Mastodon account, a LinkedIn account. I have a YouTube channel where some of these talks make it onto if and when they get recorded. And thank you very much for your attention. Um, you can find some discount codes for the books that I mentioned before here, and I'm happy to take your questions now.
Okay, thank you. Um, you mentioned that Nominati makes exact searches against database names.
That is correct.
Yeah, and at the same time, I've seen that location names use local names and local character sets. So how to cope with that? Is there any list of aliases or translation of those places? Like,
Yes, so Nominatin creates an index, and the index takes into account the tags for this place as well. So where you saw the geodata that was returned from the query, when I asked for GeoJSON, it had the local name of the place only. But its name in other languages is encoded in tags, which are in a different table. And the sort of query that I ran didn't include tags. When you create the nominatum index, you can choose to include the tags and also retrieve them through the API.
Mm.
So, in essence, when I queried it and asked for the GeoJSON of Chicago, I asked it only for the GeoJSON of Chicago. I didn't ask for any associated data with Chicago through the parameters that I passed in the query. So, to answer your question, there are translations in OpenStreetMaps for almost every place in almost every language, as long as someone has provided this translation, because we said it's a volunteer run effort and people contribute data much in the same way as contributing to Wikipedia, let's say.
Thank you.
Could you say a bit more about how the complex entities like Chicago are built out of the primitives you mentioned earlier, the nodes and so on? Like the metadata about Chicago, like what county it's in and where its center is. Are those tags or are they sort of something else that you implied but didn't specifically mention?
Let me rewind. So we talked about primitives, a lot of slides before that. Please. Nope. Primitives. The third type of primitive is relations. So Chicago, to answer your question, is a bunch of lines that are connected, that connect points, right? That outline the administrative boundaries of Chicago. So it's a way. So what I got back was a way that represented the area of Chicago. Every point inside of this way belongs inside that administrative area. It isn't encoded inside of Chicago, it just falls inside the outline of Chicago. And yes, it's a list of nodes that describe the outline of the city. Now, the relationship between those things, like, is this a municipality that belongs inside of Chicago? Is this like a neighborhood that belongs inside of Chicago? There's data like that also in OpenStreetMaps. And these are encoded as relations. So I know that the administrative center that's called Chicago contains a city that's called Chicago, and that's encoded in a relation. And that neighborhoods that are defined as separate objects are related to Chicago through a relation that encodes that they are neighborhoods of Chicago, the city, and so forth. So you know that streets also belong inside a neighborhood and they belong inside a city. So there are multiple encodings, and that's why all of this data is so complicated that it takes days to detangle and put it into tables in your database. To disentangle is the correct word. Um, so that's how relationships are represented. And because you don't want unnecessary data to clog up your database with metadata, in order to make the operations fast, right, you only need the lists of points and nodes in order to perform geographical searches and functions. That's why the tags encode the metadata. So they're stored separately, and that is why you can have 100 different names for Chicago in 100 different languages without actually returning unnecessary data for does this point fall inside the boundaries of Chicago. I hope that that answers your question.
Thank you.
Thanks. Can you ask into the microphone, please?
So you first find if the place is in Chicago, and then you or find that this is Chicago and all the names.
Right, yeah. So you can perform a join with the tags, and you can retrieve any metadata that you want directly. But services like the ones we saw, like Nominatim and Photon and so on, can also perform those joins inside of their indexes. So you can prepare, let's say, this knowledge to be served by your API. For example, you want to create an index that is useful for searches within Greece, only using Greek and English names, and you can skip all the other languages.
Hi, me again, always in the PostGIS talks. And so one answer is that Chicago will have a Wikidata tag in it, so which is valid for most cities. And then you can link to Wikidata and get what you want. I mean, translations, including names, for the most prominent features. Probably not for every tree, but for the most prominent features, you get a Wikidata link, and then you get the whole world of Wikipedia through that. My question, I mean, I have two hints. I would also mention PG feature serve in your list of software stack. PG feature serve, which serves point of interest straight out of PostGIS.
Beautiful, thank you.
And I would also mention MapLibre, GLJS, which is a modern vector tiling oriented stack as an alternative to Leaflet, which you already mentioned. And then call it OpenStreetMap without S, which you have written correctly on your slides.
I try, I mean.
And finally, did you try a GeoParquet? Because there is a company backed up by software foundation, a big one, Overture. And Overture delivers OpenStreetMap data in the GeoParquet format, so which makes that 1.5 days import even shorter, because you could efficiently, theoretically read in GeoParquet. Don't use that Overture for point of interest, because for political reasons, they replaced the OpenStreetMap data by their own data, which is a rich set you would miss out. So, but my question is, do you have experience about reading GeoParquet?
No, none at all. But thank you very much for this information. It was really valuable.
Hello, thank you for your talk. I have a quick question. As a previous questioner mentioned that there are some political conflicts around the world, and what happens with some territories that people disagree about, like which countries is and some other things. Do you know?
I do not know the policies of the OpenStreetMap Foundation, but as you can answer, but I just like to comment that as a collaborative foundation that is a non-profit, they have a board, and the board can make that decision.
That's the correct answer. There is a digital and working group which sets out disputes. I mean, edit wars, for example. But the principle and the other answer is the principle of OpenStreetMap is on the ground truth. So even if I really dislike the fact that the Russians, for example, occupying Crimea, and then if there is a Russian border control, then so it's being mapped as as a Russian, but it's really just what's on the ground. And if there are conflicts, then there are banned users who are being banned, for example, so that that bad edits will be deleted because there is a history in OpenStreetMap where you can and undelete those additions.
This is why I parallelized it with Wikipedia, because that's the way they resolve edit wars in Wikipedia as well.
Any other questions?
Thanks for the speech. What's your experience on the data updates, OSM versus the proprietary products? How fast the data gets updated?
Fantastically fast by comparison. I have been asking, because I moved recently, I have been asking for my home address, which is a new house, to be added to proprietary maps for years in some cases. They did respond with data updates. Some of these providers, they responded with data updates within their next update cycle, which can be as short as a month or 6 months or a year. So you will generally find that open data, much the same way as open encyclopedias, get updated much faster with current changes and current events.
It's minutely updated. So look for "Show Me the Way" OpenStreetMap, which is not the song, but the nice visualization that it's updated minutely in the core database. But and then it depends on those planet extracts you mentioned.
Right.
So the fact it's minutely updated, but if you have, for example, organic maps as an app on your app, it completely depends on the makers of organic maps, how fast it's up.
Thank you, which is a great point, which is another reason why you want this data inside your database. You don't want to send a request for a provider to change the data that you believe is inaccurate or wrong. You just go inside your own database and run an update statement.
Yes. As my own experience, AWS has this great open datasets feature where you can access a lot of datasets freely. I recall using their OSM dumps. They are on some S3 bucket and they were updated like weekly. So you get a new planet dataset every week if you want to. So that gives you one example of frequency of data updates in case you use those dumps. Yes, one moment.
Is it not possible to update the data yourself via some tools like Osment, for example?
You can log onto the OpenStreetMap's website and click on edit, and you can update the data in real time in the database. It may have to be approved in some cases, your edits, but you can do it directly. So your question was if you can update through an API directly.
No, but in your case, you could enter your new house address yourself immediately.
Yes, but only I would have it. The courier wouldn't have it. Because they use proprietary tools is the thing I was hinting at.
Yeah, but OSM would have it
Yes, but
immediately.
if the delivery driver uses OSM, then that's useful.
Any other questions? If not, then a great thanks for your talk. Really interesting.
Thank you very much.
Okay.